Here's a more complex example of axial deformation, and the only reason it's harder is because it requires a lot more algebra, I would say. So here we have kind of this body separated into two sections, AB and BC. It's in between two walls. P is 200 kilonewtons. The overall displacement of AC is 0.15 millimeters. We're given Young's modulus, and they want us to find PD and PA. So what is PD and PA? So let's look at them in terms of this. We have this 200 kilonewton force applied here, and eventually this force will cause a displacement, right? It'll cause a 0.15 millimeter displacement, which in the end, point C will be so displaced that it will end up touching wall D. So you're going to end up having a force PA at wall A. You have the 200 kilonewton force, and then you're going to have a third force PD at wall D, because point C is eventually going to touch wall D because of this 200 kilonewton force. So here I'm going to basically try to get as many equations as I can to solve for all of my, well, because I have two unknowns, I need two equations most likely. So the first thing is writing some of the forces here. So PA plus PD plus 200. So I end up with this. And the other equation, I know that displacement AB plus displacement BC will give me my overall displacement, which is 0.15 millimeters. So I've got two equations already. The next thing I want to do is solve for each section. So displacement AB, I cut the beam, I look at everything to the left. So I have PA and N, so N equals negative PA. I plug that into my equation, and I end up with a displacement equation in terms of PA. I do the same thing for BC now. So I cut the beam, look at everything to the right. So here I only have to consider PD. So N equals PD. I plug that into my equation and I end up with another equation where it's in terms of just PD. Alright, so now I have a few equations. Equation 1, the original one, this one, and these that I just got. So what I can do is I can plug in delta BC in here and delta AB in here, and I'll get this huge equation, right? And then I use this equation, I got PD in terms of PA. So I can use that to plug it into this second equation. So once I plug that in, this entire equation will be only in terms of PA, so I can solve for PA. Right, so I plug in here, it's just a bunch of algebra which you're going to have to hash through, and once you end up solving through it, you should get just PA equals negative 179.6 kilonewtons. So you found PA. To find PD, then the next step is pretty easy, because you know PA plus PD equals negative 200 kilonewtons. So plug in PA into here, and you have PD equals negative 20.36 kilonewtons. So I would say the hardest part here is just going through all of the algebra. But yeah, that's one of the harder problems.